So the Pythagoras theorem states that a squared plus b squared equals c squared. It's important to note that the relationship is not about the side A, side B, and side C. We can see that those three sides, they are not connected to, they're not related to each other. The relationship is through the three squares. Okay, so this area here, a square, and this area here, b square, these two areas together make up the area c squared. And that is the Pythagorean relationship. It's not about side A plus B equals C. We can never say that. Okay? A plus B is never equal to side C. It can't be. It's impossible. It's physically impossible for A and B to add up to C. Okay? Because C is always going to be shorter than the A and B together. Okay? So this is not true. In fact, I'm going to leave that up there because A plus B, side A plus side B, does not equal side C. What is equal is a square, the square, plus the other square, the two smaller squares, add up to the big square. Okay, so we can use this relationship to find the side length, but it's the relationship, the equation is actually through the squares, not through the lengths. So then we can use this relationship then to find unknown sides. Okay, so if I go 10 plus 4 equals 14, well, that doesn't make any sense. That's clearly incorrect. This x is far shorter than 14. Okay, it can't be 14 because 10 and 4, if I line them up straight, this will never match that length. But what will match is this square, so 100 squares here, and 16 squares here, will equal 116 squares off this side. Okay? Well, that makes this x length the square root of 116. So that indeed is true. And now we can work out the length of that side by square rooting the area that we could calculate through the relationship. So the area is 116. So when I put this into my calculator, okay, so 116 square root is going to give me approximately 10.77, which it makes much more sense because that length x is certainly not 14. It's very close. It's a little bit longer than this line here. 10.77 seems about reasonable. Okay, so for this one here, we have this area is 9. Okay, this area is going to be 36. Now, if I said 9 plus 36 and said that this square is 45, that would not be true. Okay, because this square is definitely bigger than this one. Okay, this is the longest side. So if I want to find out the area here, what I can do is subtract. So this square here is equal to 27 squares. Okay, so I'm going to write squares. So if I want to find out the length of the side, area to side length, I square root. Okay, so it's going to be square root 27. I'll write this out a little bit nicer. This is going to be square root of 27. And if I were to work this out, it's a little bit longer than 5. It certainly can't be as long as the longest side of 6. So if I do 27, okay, square root 27 is 5.19, about 5.2. That's about right. Okay, so 5.2 approximately. Okay, and that length is just a little bit shorter than the diagonal length here. This one here, if I want to find the shorter side, I need to take the same approach. I'm going to take this big square here. This is 289 squares here. I know I have 14 square, which is 196 squares here. And these relate to this square area here. So if I take 289, I can't add these because clearly this area is smaller than this one. But if I take 289 and subtract 196, I'm going to end up with 93 squares here. Okay, if this is 93 units squared, then the x length is going to be the square root of 93. So going from area to side length, I square root. Okay, so then my area to side length, square root of 93, is about 9.64. Okay, so this is x is approximately equal to 9.64. Yeah, that seems about right. This is not drawn proportionally, but 9.64 makes sense. Yeah, those areas seem to match up. This area plus this area add up to the big area. So if I want to find the unknown area, I'm going to subtract those two areas.